Good day everyone, I'm Joshua Miguel Relota, BS ECE23A. I will discuss about CPFSK, which means Continuous Phase Frequency Shift Keying on how it operates. Continuous Phase Frequency Shift Keying, CPFSK. Continuous Phase Frequency Shift Keying, or CPFSK, is a popular variation of frequency shift keying, FSK, which is an analog frequency modulation special case. FSK is a method of modulating digital data onto a sinusoidal carrier wave, encoding the data's information to changes in the carrier instantaneous frequency between two frequencies, referred to as the space frequency and mark frequency. The modulated waveform alternates immediately between two sinusoids with differing frequencies. Hence, a standard FSK signal does not have continuous phase. The phase of a CPFSK is continuous, as the name implies. This property is advantageous for signals to be broadcast across a band-limited channel, as discontinuities in a signal introduce wideband frequency components. Furthermore, when driven with almost discontinuous signals, several amplifier classes exhibit nonlinear behavior, which could have unfavorable consequences on the form of transmitted signal. ST is equal to AC times cosine 2 pi FCT plus df times the integral of m alpha from negative infinity to t d alpha. The corresponding CPFSK signal is where AC is the amplitude of the CPFSK signal, FC is the base carrier frequency, and df is a parameter that regulates the frequency deviation of the modulated signal if infinitely valued digital signals to be broadcast. The message is empty. The CPFSK signal's continuous phase is determined by the integral contained within the cosine's argument. An integral over any finitely valued function which empty is presumed to be will not contain any discontinuities if the message signal is supposed to be causal. The integral's lower and upper bounds shift to 0 and t respectively. Phase trellis of a triple H CPFSK with H is equal to 0, 1/2, and 1. Phase trellis of the triple H CPFSK scheme with H 0, 1/2, and 1 is shown in the last slide. Its implementation is as follows. The add of the input binary data is used to decide H. H is equal to 1/2 is corresponding to data 1. H is equal to 1 is corresponding to data 0. The even bit of the input binary data is utilized to decide the phase slope. During a symbol interval, if the even bit is 0, the corresponding slope during this symbol interval will be h pi is equal to t. Else, if the even bit is 1, the corresponding slope during this symbol interval will be negative h pi is equal to t. However, if h is equal to 1, the phase slope will be pi over t or negative pi over t. According to this mapping rule, this will cause a phase faintness. The phase difference between the different input binary data at the next sampling time will be 2 pi, and thus it is difficult to demodulate the next symbol. Therefore, to eliminate this phase faintness, h is equal to 0 is introduced to the proposed scheme. If h is equal to 1 and the even bit is 0, slope pi divided by t will be adopted. Else, if h is equal to 1 and the even bit is 1, slope 0 will be selected. Then the encoded H CPFSK signal is sampled every T, and the sample data sequence is fed into an inverse class Fourier transform IFFT module to generate the H OFDM CPFSK signal. At the receiver, the H OFDM CPFSK signal is demodulated by a FFT module. Then, to get the received binary data, a simple differential decoder is demonstrated, as the phase state of the present symbol is determined by the cumulative phase of the previous symbols and the input binary data at present. We subtract the phase state of the last symbol from that of the current symbol. The subtract is only determined by the current input binary data. Then we can get the current input binary data from the subtract directly. The decision block of differential decoder is shown in the figure above. After angle block, phase is limited to negative pi. Therefore, the differential decision block is limited to negative 2 pi to 2 pi. Summary: continuous phase shift keying CPFSK is a popular variation of frequency shift keying FSK, which is an analog frequency modulation special case. ST is equal to AC cosine 2 pi FCT plus DF times the integral of M alpha from negative infinity to T d alpha. CPFSK is under MSK, means minimum shift keying. Thank you, that's all.